Hello YouTube! And this is the second episode of the series. In the first episode I showed you how to use BitTorrent technology to download music, films and software securely. In this week's episode I'm going to cover encryption. I'm going to give you a step-by-step tutorial on how to protect the confidentiality of your personal data using secure encryption. We all have personal and private lives which we wish to keep out of the public domain. This video will give you the knowledge, tools and confidence you need to guarantee that your data remains secure. From prying people, hackers, government organisations, we all know the police, GCHQ and other security agencies all over the world are spying on us. Tech companies are facilitating government spying and also violating our privacy for their own commercial interests on a grand scale, using algorithms to log, review, retain all our communications data. Privacy is a fundamental human right. We all have a right not to be under constant surveillance, regardless of circumstance, justification or authority of any third party. This video will give you the confidence you need to ensure your data remains private and under your complete control. This tutorial will show you how to encrypt data on your computer's hard disk and on external disks such as USB flash drives. This will protect against somebody accessing your data in your absence without your knowledge if your machine or your system gets stolen or lost. Once encrypted, you'll be able to also back up the data to a less secure medium. For instance, you could back up the container, the encryption container, to Dropbox, Microsoft OneDrive. You will have complete confidence that the hosting company won't be able to see or otherwise interact with your data. The host can't apply any algorithms, they can't apply any surveillance techniques or tools. What they see is basically jumbled up bits of data which they can't make sense of. This episode is going to use VeraCrypt. VeraCrypt was based upon the legacy TrueCrypt software. It's been around for a number of years. It's very secure. You can use multiple encryption algorithms as additional layers of security. Also, in another video, I'm going to show you how to use the inbuilt functionality in Microsoft Office. But I wouldn't recommend Microsoft Office over VeraCrypt, because VeraCrypt you can use with any forms of data, any formats. You can encrypt images, text, videos. It really doesn't matter.
If we start the tutorial, the first thing we're going to need to do is download VeraCrypt. To do that, we open any web browser, go to a search engine, in this case Google, and we need to do a search for VeraCrypt. I already know the extension is, but for the purpose of this video, we're going to do it from the start. Okay, this is the actual link. It's a .fr extension, which is a French extension. Okay, this is VeraCrypt's website. VeraCrypt is an open source, freely available utility used for on-the-fly encryption. You can create virtual encrypted disks within a file, or encrypt a partition, or the entire storage device with pre-boot authentication, which basically means you have to enter a password before you can boot your computer, before even Windows is decrypted to start. VeraCrypt is a fork of the discontinued TrueCrypt project. It was initially released late 2013, and the current version was released on the 12th of September 2018. There's been many security improvements since TrueCrypt ended. It's important to note that TrueCrypt successfully underwent an independent security audit, and it passed with flying colours. And since it's morphed into VeraCrypt, there's been a number of improvements. The software is available for Windows, Mac, Linux. You can also view the source code if you wish. But for this example, we're going to be looking at the official installer. There's also a portable version if you want to run it from a USB key, for instance. Okay guys, don't be too concerned about the fact it wasn't updated last until 2018. You shouldn't expect regular updates on this sort of software it's using very powerful algorithms that have stood the test of time. Algorithms such as AES, Serpent, Twofish, they've been studied for many years, decades even, and they are known and famous for being relatively secure. The maths behind the algorithms is very secure. It's more of how they get implemented through the software. That's where bugs can come in. But the mathematics is absolutely sound, and has so far stood the test of time. And numerous researchers are constantly probing VeraCrypt and other implementations of software such as this, and it's very rare for any major issues to be identified. Okay, so once we've downloaded it, I've just clicked launch. So basically it just wants to install. Absolutely fine. Obviously I haven't virus checked this download because I trust the source and I'm using it on a virtual machine just as an example. But if you're using your home machine, just give it a quick virus check just to make sure everything's fine. I've got no reason to suspect it isn't fine, so I'm going to allow it to go. If I shut the browser. Okay, select your language. There's a number of different languages you can choose from. French, Dutch, English is what we're going to focus on for this tutorial. Okay, it is open source software, but just give it a tick on the licenses. Next. Okay, we want to actually install it. Next. Install for all users. So if your computer has multiple local accounts, you might want to install it for your girlfriend, your friends, or wherever. Add VeraCrypt to start menu, yes. Desktop icon, yes. And associate any encrypted files with VeraCrypt, yes. So install. This will be extremely quick. It's only a small package. Okay, once it's installed, just click OK. Just click finish. Now, this obviously I'm doing a tutorial for you, but if you want to brush up on something later on, or you're concerned about something, just view the tutorial. You can always view this later through the menu anyway. Okay, now that we've installed VeraCrypt, we need to give it a launch. Obviously, you just double click the icon. Or if you want to search for it through here, just type VeraCrypt. There it is. Okay, you'll be confronted with this menu: volume, system, favorites, tools, settings, and help. The help menu, if you go to beginner's tutorial, if you ever get stuck, please consult here. But in this video, I'm going to show you what to do. Okay, firstly, as you're new to VeraCrypt, you'll have to create a volume. Forget about the other options for the moment. The first thing we're going to do is create a volume. Selection, create an encrypted file container. You can also choose the mid one, encrypt a non-system partition drive, or encrypt the system partition or entire system drive, which means when you press the on button on your computer, you'll be prompted for a password before Windows and any files on the drive itself is decrypted, and then Windows boots. Very, very secure. But in this case, we just want to protect a small file. If you click next there, okay, you create standard volumes and hidden volumes. The difference is, with a standard volume, it's one volume, whereas a hidden volume is technically two volumes. You've got the outer shell volume and the inner shell volume. Two different passwords. They're both as secure as one another, but the difference is you keep less secure data in the shell 1, or the outer volume, and more personal or sensitive information within shell 2, the inner hidden volume. If you're forced to reveal the password for whatever reason, perhaps there's a government warrant or something like that, you give the password to the first outer shell, the less secure area, so the real data still remains secret, and there's absolutely no way for them to know that the inner shell exists. So you're still complying with the request to hand over the password, but they still can't get to the genuine data, and there's no visibility or methods for them to actually reveal that the hidden volume is there. So if you click on hidden volume, next. Okay, you can either do it directly or normal. Normal is absolutely fine. It'll give you a step-by-step process. If you click next. Okay, make sure never save history. Don't need that. Okay, here you have to create a file which you want to be the container. So I'm going to go on my desktop. You can put it anywhere you want. Create a text document. Call it data. And on the select file, select the file we just created. It doesn't matter on the size, you get to resize it in a moment. Click save. Do you want to replace it? Yes. There you go. And now you go next. Right, this is the outer volume, the less secure area. So if we click next. Right, here is a very important bit. You want to be on the safe side, you want to use 3 different algorithms. It'll be a bit slower initially when you're encrypting the full drive, and it'll be very slightly slower when you're decrypting it, when you're entering the password to mount the drive. But it's such a small difference, you're talking milliseconds, so you really want that 3 lock system. What this means is, if in the future there's a security vulnerability in any one of these algorithms, there would have to be a security vulnerability in all 3. Because although they can get through the first lock, effectively it's still double locked. And the chances of an adversary, even the government, cracking 3 different algorithms that have stood the test of time is extremely remote. What I would go for is AES, which is industry standard, extremely secure, 256-bit. Twofish and Serpent, extremely secure. And the hash SHA512, absolutely fine. Click next. Right, this is where you specify what size you want this container to be. And I would advise you to put it larger than what you need, simply because although it might fit your requirements today, if you get more photos, video, or whatever data you've got and you want to put it in a later time, you can resize the drive, but I really wouldn't recommend that. It's best to get the drive nice and big to start off with. As this is just a test, I'm going to put it at 1 gig. So 1024 megabytes. This will tell you how much space you've got on the drive you've got selected. Remember, this is the outer shell. So the outer shell has to be bigger than the inner hidden shell. So think of it as Russian dolls. The hidden one is the smaller one. So the outer shell is a gig. Right, the password. I would recommend you that you have at least 20 characters. Do not use words. Do not use anything you'd expect to see in a dictionary of any sort. Do not use places. Do not use names. What you should be using is random, uppercase, lowercase characters with numbers and symbols. I'm going to show you in a notepad of a good password. This is an example of a good password. Something like that is absolutely fine. I'd recommend 20 characters, but as this is an example, that's fine. So just copy that, right? Paste that in there, paste that in there. I display the password. There it is. Don't need to tick any of these, leave them unticked. Obviously, the password of the hidden volume and the outer volume need to be different, very important, and they should be significantly different. The password is what you use to unlock the drive, so you obviously can't use the same password, otherwise it'll unlock both drives. And if you're handing over the password by force to the outer shell, you obviously do not want to reveal what could be the password of the hidden shell, so it's very important that they are different. So if we go next. Okay, on this screen, it's going to create the outer volume first, and you're selecting the file system. It's best to use FAT for the outer volume. Leave the cluster as default, that's absolutely fine. And if you notice, when I move my mouse, this bar goes up quicker. That is simply because it's using the random coordinates of the mouse movement to generate a random pool. This is used for the encryption. The more random this is, the better. So just keep moving your mouse around within this window. Wait for the bar to go green. I do recommend you continue to do this for at least 10 minutes, because this is really important. Okay, for the process of this video, that is fine. Click format. Okay, this is where it's going to do the formatting. Don't be worried with this, delete it, that's fine. This is an empty container, there's nothing in it, it's purpose built. Obviously, you should not have any data within the container yet. Although this is a text file, it could be a folder, it could be a picture, it really doesn't matter. Do you want to replace it with a TrueCrypt container? Yes. Give it a few seconds to do its stuff. Obviously, because it's only a gig in size, it will be relatively quick. If you're doing this on a grand scale, like a 20 terabyte hard drive, this could take up to 12 hours or even more. But that's only initially. So once you've done that, you've done it. When you're mounting the drive and using it on a day-to-day basis, it will take nanoseconds. Okay, fantastic. Now you can actually open the outer volume, and there it is. So where is this outer volume, you're asking yourself? It's because it's mounted. So if you go to your PC, there is the virtual volume. Obviously it's under a gig in size, simply because they're formatted. But this is the outer volume now, and you treat it like any other drive, like a USB flash drive. You can put folders in there, you can create text documents, you can put whatever you like in there. Just another drive, just a virtual encrypted drive. This is the outer drive. So we got two things in there, so if I shut that. Now if we go next, now we're going to do the hidden drive. So we're going to go through those steps again. Let's click yes there. Okay, next. Right, keep everything the same as previous. We want the inner drive to be exactly as secure as the outer. Next. Right, this is the important bit. It must be less than the outer shell, because it goes in the outer shell. So I'm going to put this as 500 meg, which is roughly half the size. Next. Right, the password must be different to the original. And if you look at the original password, that's the original password we used. So what password I'm going to use is something just as long and just as complex, but different. And I would recommend having the outer volume password smaller than the inner, simply because the hidden volume is where you're putting most of your security, so that should have a slightly longer password to protect against brute force attacks. Okay, there's the new password. Obviously this is just an example password, you should make it up yourself. And if you're worried about forgetting the password, I do recommend you print it off in like a size 8 on multiple pieces of paper, and just hide the paper in random places. Now I do recommend you print off and save the passwords to a certain extent. I would personally print off the passwords in like a size 6 font, laminate the piece of paper, and put it somewhere random. Do not keep it in your house, do not keep it with the drive. If you've got an office and work, and just literally put it in a filing cabinet somewhere. Anyway, out of the way, anyway that somebody could pick up the piece of paper and they wouldn't even notice what it was. Even rip the sides, you know, scrimple it up and put it in the back of your cupboard. Just so if you forget the password, you always have the backup. But if somebody was to discover the paper on its own, they would have no reference to what it means or what it's for, so it'd be useless to them. And I would do this in multiple places. Right, fat is fine. You can change this to NTFS if you like, but for this instance we'll leave it as default. Obviously again, move your cursor as much as you can to get the random pool. It's more important at this stage simply because the hidden volume is more important than the outer volume. Is what we really want to protect. The outer volume is more of a decoy volume. And when you're putting data in the outer volume, you want to put a little bit sensitive information to not make it obvious that you're hiding information elsewhere. So you put your CV in there, you put low utility bills or something like that. But any serious or very sensitive information would go into the hidden volume. You should do this for 15 minutes, if not more. Click Format. Same steps again, be slightly quicker this time. It's just basically rehashing the volume because it's already encrypted in that, no ciphers, etc. You have an outer volume that's a gig in size, and you have an inner volume that's 500 in size. So the 500 meg has obviously reduced the outer volume size to 500 meg. So in theory now, if I mount the outer volume, I could put a gig of data in that volume. But if I did do that, I would overwrite the hidden volume which you can't see. So very important, any data you put within the outer volume is less than the space you've allocated to it. In this case, I've got 500 in my outer. If I put any more than that, I will overwrite the hidden volume. And you don't want to get into corrupt files and things like that, not with encryption. So click OK, click Next. We don't need any of this anymore. Click Cancel. Okay, now that you've created the encryption container, here it is. If you select it, go to Properties, you can see what size it is, 1 GB. It's just a giant text file from any other person's point of view, although we know different. Right, to mount the drive, that's where you create a virtual drive. If I show you where it'll be, if you go to my computer, this is where it'll be as a virtual drive. It's not there yet because we haven't mounted it. Select a letter, any letter that's free. I tend to use Z, which is fine. Select file, it's already selected, but if you go through it from step 1, SPC, desktop, data, which is that, select, open. Now, you don't need to worry about the volume tools and auto mount, and you don't need any of those yet. Just click mount. Right, don't worry about any of these. It's important that you do not display password, because if anyone's monitoring your machine or can see what you're seeing, a screen capture software, anything like that, you really don't want to use that. It's vitally important you keep the password secret. Likewise, if you're using a USB keyboard connected to your desktop computer, I would highly recommend that you use the onboard keyboard. If you've got Windows 10, and I believe it's in all versions of the OS, just click that and simply select there and type your password in. That prevents any keyloggers getting to your password, and keyloggers extremely cheap and easy to use. Literally, an attacker who's got physical access to your machine could put a keylogger between your USB keyboard and your main computer. Your main computer will not detect it, so any antivirus you got or security simply won't work. They just leave you use the machine for a couple of days, come back a couple of days later, physically remove the keylogger, and then they just access the keylogger like a USB stick, and they've got every password or data you've entered. And what normally happens if you go to a website, the first thing you're going to do is put in your username, which is normally your email address, and then they know straight away from the log the next line is going to be your password. That's why it's important that you use two-factor authentication wherever possible. In this case, I've got my password in memory of the computer, so I've just entered that. Click OK. Now it will mount the external shell on Z drive. So if you go to my computer, it should pop up here any moment. Successfully mounted. There's the size, etc. Now this is where it tells you what volume you're currently mounted. In this case it's normal. Anyways, there's the drive. Now earlier on you did see me put some files in here, but I've deleted them since. So if you put another file in here, like test, okay, that's the outer. Okay, I've got 500 meg that I can actually use. It showed me a gig. As I said previously, you can only use the space after the hidden volume's being taken away from it, and the hidden volume is 500 meg, so that leaves me with roughly 500 meg. I always play it safe, never use too much of the outer, because you really don't want to risk the integrity of the inner drive. Okay, that's that. That's treated like you would any other drive. Right. Now the outer volume's mounted, you put in your CV or whatever other less sensitive information you want to protect. Now the next question is, how do I dismount, how do I encrypt the drive? So all you got to do in here, now you can technically pull the power on the PC, which will automatically decrypt the drive, but I wouldn't recommend that because you could corrupt the partition. So what I would do is go in here, safely select the drive, simply click dismount. That's all you got to do, click dismount. If you copy that partition to an external hard disk, you can back it up and treat it like any other drive. If you copy that to an external drive, dismount it using VeraCrypt, then obviously disconnect the drive as you normally would with a USB drive. Right, next I'm going to show you the hidden volume. So if you launch the software, I have to shut it. If you launch it again, some principles as before. History is turned off, which is what you want. You don't want to give anyone the advantage of knowing the files you've been mounting, as that flags what is encrypted, what isn't. Open it, mount. Right, now I'm going to try and mount the hidden drive. I'm going to go here and copy the password. Obviously you should not have the passwords on the computer in any way, shape or form. This is simply a tutorial to make it easier for myself. These are not real drives. I'm not going to be using these drives. Once this tutorial is done, I'm going to be deleting them. So yours should be, you can write them down as I said, print them off, and keep them well away and disconnected from yourself and the drive as possible. I recommend you do not keep them in your own house. If you just mount the external drive in the identical fashion to the outer shell. Now you can't mount the outer and the inner at the same time. So you will have one working at any one time. But once you've put the decoy information in the standard drive, you've got no real reason to use that. You should be using the hidden drive for any major information. That also protects you from accidentally overwriting the hidden drive. There we go, that's mounted as expected. There's the size 499, slightly under what we specified, but that's what the headers. It states here as hidden, which we know it is. If you go back into my computer, there it is. It'll look identical to the previous drive. And this is basically an encrypted drive within an encrypted drive. So here you put your top secret data, sensitive information, whatever you want. You've got 500 meg in this case to play with, for your images, your movies. It doesn't matter the file extension, it absolutely does not matter in any way, shape or form. You treat this as a dumb drive. Shut that. And again, same principles as the outer shell. Once you finish using the shell, you can simply dismount it, and there we go. So this should be backed up regularly to numerous systems, because obviously this is your data, so you need to ensure it's protected, and vice versa. You need to also protect the password. One or the other without the other is no good. They're only good when they come together. So do not leave this as your main and only container, because if your hard drive fails or becomes corrupt, use your data. Right, if you launch VeraCrypt, I'll show you some of the other options. Now, there are a number of features you can use. If you go to System, you can actually change the password for the volumes. The only reason you'd want to do this is if you think the passwords you're using have become known, or you suspect they've been compromised. That's when you change the password for each, the outer shell and perhaps even the inner shell. If you go to Tools, I would recommend you back up the volume headers in case things can get corrupted. It really help recovering the data. But if you took my advice earlier and keep a full backup of this on a USB hard drive somewhere, that's what I would recommend, because if this gets corrupt through the use of this PC, I've got a full backup. Obviously it's the same passwords, it is a carbon copy of one another. Although the data is encrypted, you should still keep that backup physically protected in a locked drawer or something like that. It's hugely unlikely anyone will be able to crack it, especially with today's technology. It's always best to be on the safe side. You can permanently decrypt the volume if you wish, for whatever reason. Maybe you decided that the information you're protecting no longer warrants that level of protection. If you ever need any help, you've got the user guide, online help, beginners tutorial. There's lots of forums and online chat about encryption and how to use the software. I'd highly recommend you use it. Keep up to date with the versions. They do tend to fix bugs, not very often, probably once a year. But it's always nice to get little things ironed out. But all in all, this is a superb package, especially considering it's free. It's passed audits, it's well known, it's extremely powerful, it's as of yet, it's uncrackable. We know this is uncrackable because in the Snowden files, which are leaked by the NSA, there's actually documents in there specifically referencing TrueCrypt. It's before VeraCrypt's time, but TrueCrypt saying that they couldn't get access to it. They were actually targeting the host system, the computer itself, to get access to a drive which has already been decrypted on the computer. If you need any further information or help, have a look in the description of this video. I'll put some links to the forums and other sources of information.
Thanks for watching, guys. I hope you found the video enjoyable and useful. If you've enjoyed the video, please consider giving it a like, comment and subscribe. Every week I'm going to be bringing new content, new tutorials, new reviews and any other interesting content I can think of. On next week's episode, I'm going to show you how to skewer and change your DNS.
DNS stands for Domain Name System.
It's what your computer and your browser uses to resolve queries. I will show you how to use third-party DNS and use the encryption provided within your browser. You not only are using a different directory services, but you're also encrypting the link between you and the directory to prevent any snooping or any interfering by any man-in-the-middle attacks. This will really help you ensure your privacy, prevent censorship, prevent control, allow you to be free online. Follow me if you want to browse anonymously, maintain your privacy or protect your freedoms. I can give you all the knowledge I know.